The second law of thermodynamics explains that energy flows from a high state to a low state. So energy is transferred from a hot object to a cooler object. The heat in your coffee is lost to the air that is colder surrounding it. There are three ways of transferring heat energy. One is conduction, which is basically electricity, where from atom to atom, from electron to electron, energy is transferred. Second is convection, which is the movement of heat by fluid. This could also be air, where hot air goes upward towards the outer space. Radiation, which is light basically, and that's how energy is transferred from the sun all the way to the earth. In stars, there is only one type of star called a white dwarf that transfers the energy via conduction. Otherwise, all stars transfer energy via what we call convection and radiation. In stars that have less than half a solar mass, or mass of the sun, the energy that is made in the core is transferred to the upper layers via convection cells. Giant cells of hot gas, plasma, move up and they transfer the energy of the core to the outer layers. In the sun-type stars, between half to 1.5 times the mass of the sun, the energy is transferred via light, via radiation from the core outward, and then on the upper layers is transferred via bubbles of gas again. Convection cells move the energy from the lower to the higher layers of the sun. In massive stars, more than 1.5 the mass of the sun, we have a convective core. Now this is very important because this brings fresh fuel, like fresh hydrogen, to the core so that it can burn at very high and efficient rates. And this helps because we have virgin hydrogen, untouched hydrogen on the outside of the core. We can bring this untouched hydrogen, we can burn it at very high rates. Kind of like fuel injecting a car. It's in the outer layers in the massive stars that energy is transferred via radiation here. So it's the opposite of the sun. When we compare the size of the core in the sun to the size of a more massive stars, the smaller stars actually have a larger core as compared to their size than the larger stars. In the sun, the energy is transferred via radiation from the core, where the energy is made by fusion. So the energy moves outward very, very slowly. It might take 100,000 years, it might take 1,000,000 years for the light to transfer the energy of the core to the outer layers. And then when it gets to the outer layers, then bubbles of moon-sized gas, moon-sized plasma move the energy the rest of the way, and then when the bubbles cool down, they come back down. So there is this motion of hot gas going up, cooling down, and then coming back down again. And this happens over and over and over. The light, when it leaves the core, it's moving at a very random motion. So it could travel for a long, long time before it can reach the outer layers. So this random walk is random walk, meaning that if you blindfold yourself and you wanted to leave a large city, you don't know which direction you're going. So you're taking a random walk and eventually you might end up in the core of the sun again. For that reason, it may take a long time for energy to move from the core of the sun to the outer layers. The motion of plasma or ionized gas is very random in the sun. The protons repel each other, the electrons repel each other, and the electrons and protons are separate. So the electrons travel in an ocean by themselves, protons travel in an ocean by themselves, and the light is trying to move out in amongst all of these atoms and somehow make its way to the higher levels. We can see the bubbles when they reach the sun's surface. So the sun doesn't really have a surface. This surface is moving bubbles of gas about the size of the Earth's moon, and they come up here, they dissipate the heat, and then they move back down again. We can see this motion. The dark areas is where the cool gas is going down, and the bright areas where the hot gas is coming up. The entire sun is covered with these, what we call granulus. And the effect is called granulation. So the whole sun is covered with granulation. They're basically bubbles of hot gas that are going up to the surface, carrying the energy, and then they cool down and go back down again. So there's continuous moving of these plasma ionized gas bubbles going up and coming back down, going up and coming back down, moving the energy upward.